It's Taran from Margin here, and today I'm going to show you our new Python strategy editor. To open it, go to the strategy selection menu, pick Python strategy, and click on Create. On the left, you see the Python strategy editor interface. It consists of the status bar, which will indicate the current state of the running strategy later on. Then we have two tabs, the Python code editor tab and the run strategy tab. The Python code editor tab will be used to write your strategy. The run strategy tab will be used while running the strategy. Below that, you have the strategy output widget. This will contain any output that is generated by the strategy. In the Python code editor tab, we can see three icons on the top. Below that, there's the window containing the user-written code. Here we will implement the strategy later on. The first icon is there to save the strategy, run some simple syntax checks, and call several functions, for example the init function. If there's an error in any of these calls, you will see an error message and the corresponding line will be highlighted. We will see that later on. Next to it, there's the detach button. This allows you to detach the code editor widget and place it wherever you like. For example, on the right side, on the bottom. Let's leave it here. You can return it by clicking the attach button here again, the reattach button there, or simply closing it. It's also possible to make the widget full screen. The next icon is the show documentation icon. This will open up another widget, which can be placed anywhere you like. The documentation contains first of all some general information about how to code your own strategy. It will also give you some information about the main components that are available to you. Below that, we have auto-generated documentation for every important class. First of all, there's a strategy base class. From this, we will inherit our own strategy in order to implement the functionalities. Besides that, there's the strategy configuration, which is also very important, and then there's several data types like candle, order, etc. Besides the editor widget and the documentation widget, also the strategy output can be detached and placed wherever you like it. If you place it over here, for example, you can get a much better overview once there's a lot of output. Now let's try and see if there's output generated by the strategy. For example, if I click the save button, we will see some output here. Setting up user strategy is an output that's generated by Margin. Next on, we see strategy init function. This is an output that is printed when the init function of your strategy is called. Afterwards, we see strategy successfully saved. This means that the strategy was saved without any errors. Okay, before we get to coding, I will remove all the comments from the code. These are in there to get you started on coding without having to dig too deep into the documentation. They are placed next to every function that needs to be implemented to guide you through the way. Before we will code a small example strategy, let me give you a tour of how to code your own strategy in general. For this, I will expand the code editor to full screen, go to the top. We always implement a class called strategy, which inherits from strategy base. Below that, we will override some functions of strategy base, which will be called from Margin. There's, for example, the init function, get strategy config, and all the other ones. Besides the functions that we override, the strategy base class also contains a range of functionalities that can be used to make the strategy work the way you want. But let's go through the functions that we need to override. First of all, there's the init function. This function initializes your strategy. It's the first function that is called. The second function that's called is the getStrategyConfig. This returns your strategy configuration, which will later be used to determine what kind of updates your strategy needs to receive. For example, order book updates, ticker updates, public trade history updates, or funds. We also have the save strategy state function and the restore strategy state function. These are used to restore your strategy after margin was closed, for example. Next up, we have the start function. This is the first function that is called when you press start for your strategy. Here you have to implement everything that needs to be done to get your strategy started. Then we have the stop function. This is the function that is called when you press stop. Here you may have to ensure that nothing is running in your strategy anymore. Same goes for the suspend function. If your strategy gets suspended, please ensure that there's no threads running or anything like that. Unsuspend will indicate to your strategy that it's no longer suspended and you can resume your activities. Below that, we see the update functions, for example, new order book, new ticker, new public trades, and new funds. These functions will only be called if you specify the corresponding flags in the required data updates. Next up is the order update function. This function is called whenever an order that your strategy placed is changed. This can, for example, happen if an order gets filled, is adopted by a user, is partially filled, or some other change occurs. Then we have the on-place order success. This function is there to give you an asynchronous feedback after placing an order. When you place an order, like in this example here, you will receive a place order ID right away. That doesn't mean that the order is already placed on the exchange. When on-place order success is called for the given place order ID that you received from the place order call, then you will know that the order has actually been placed. You can check whether your waiting order ID is equal to the place order ID, or if you are sure that you only placed one order, you can ignore this part. If your order couldn't be placed, the onPlace order error string function will be called. It also contains the place order ID as an argument to identify the order that failed and contains an error what went wrong. The onCancel order success is correspondent to the onPlace order success. This indicates that canceling an order was successful. The onCancel order error string is similar to the onPlace order error string and indicates that canceling an order went wrong. The demo strategy we are going to implement today is a lighter version of Margin's ping pong bot. To begin, we are going to add an area at the top of the strategy which is going to contain user variables. For now, Margin's Python strategy editor doesn't support for you to add UI definitions, for example amount sliders or price range selectors, but this feature is going to be added in a future version. For now, we are going to have to set user variables in the code. So for a ping pong bot strategy, what variables could the user want to set? First of all, we have buy and sell price. Then we have the amount that is going to be traded. And the user might want to select whether the bot should start on buy or sell side. So, for example, a variable like this. Okay. Now let's go through the functions one by one, starting with the init function. The init function is the first function that is called on the strategy. And in our scenario, we can use it to let the user know what the expected effective gain of his strategy is going to be. In order to calculate the effective gain using the user variables, we first need to get the trading capability manager. The trading capability manager can be used to check orders for their validity, to calculate due buy totals or sell totals that you can receive when placing a specific order, etc. In our case, we are going to need the buy total, which we can calculate as follows. So as you can see, we need the amount and the buy price to calculate the due buy total. This also includes fees that might be added by the exchange. We also need the sell total. Which uses the amount and the sell price. We can now, using these two variables, calculate the effective gain of the strategy, first an absolute value and second as a percentage. The effective gain and effective gain percentage are both calculated in relation to one single iteration of buy and sell. Now we only need to let the user know what the effective gains are. For example, like this, where we add our variables. The get second currency function returns the string that contains the name of the second currency on the pair that we are trading. Now this is it. The first thing that we are going to do when the strategy is started is place an order on the user selected side. In order to do so, we first have to select the correct price. namely the buy price if the user selected start on buy side to be true, and else the sell price. Next, we're going to place the order. This is done by calling place limit order on the strategy, which takes in 3 parameters. The first one is a boolean that defines whether the order is placed on the buy side. Here we can just pass in start on buy side. The second is the order amount. And last, the price. It is always good to check the order for validity before actually placing it. In order to do so, we are going to use the Trading Capability Manager again. The isOrderValid function of the Trading Capability Manager takes the same arguments as the placeLimitOrder function of the strategy. And it returns a boolean if that is true if the order is valid. So we can assert correctness of the order like this. If you want to know which function to use for a specific purpose, or how a specific function works and what its parameters are, you can either look it up in the documentation, or you can look for the information in a more interactive way. For example, you can enter help for strategy base, then click save, and the specific documentation will be shown in the output widget. Let's make it larger. You can see now strategy base class documentation starts up here, and you can see all the functions involved below. Now let's look for the place limit order function as an example. There we go. Here you can see what the call parameters are. First is the strategy base class. Second is the boolean determining whether the order should be a buy order. Then there's the amount and the price. Below you can see a description what the function does. Here, for example, it says that after calling the place limit order, you will get the order placing ID as a return value. Then either place order success or on place order error string are called after the order is actually placed. This is done because place limit order is an asynchronous call, which might take a while. So you will get a notification once the action is completed. Let's go back to the strategy editor and take a look here. We can now see the onPlaceOrder success function below and the onPlaceOrder error string function as well. These can be used to handle the success or error case of the place order function. We just learned that the place limit order function returns an order placing ID. This ID can be used to, in the success or error case, determine whether the success or error belongs to an order that we placed in our strategy. In the default implementation of the strategy, there's already a waiting order ID variable created in the init function. So let us use this one. We assign the result of the place limit order function to this variable. Now let's check out the onPlaceOrder success function and the onPlaceOrder error string function. The error string is already handled correctly. The strategy will exit once there's an error placing an order, as we don't expect this to happen for now. In the success case, we first check whether the place order ID that we get in the function call is identical to the waiting order ID that we stored before when placing the order. If this is the case, we want to handle the success. In the other case, for now, we just print that we did not have the waiting order ID for the given place order ID. Now, if the success belongs to the order we placed, there can be two separate cases. First of all, the placed order could already be filled. We can check this by looking at the remaining amount. If the remaining amount of the order is 0, this means that the order was already filled. In this case, we want to place an order on the opposite side. But let us take a look at that in a bit. In the other case, the order is now placed and we can store the order in another variable. Don't forget to clean up the waiting order ID variable, because it is no longer going to be used. Now, we already implemented the placing of an order in the start function, so maybe we can reuse it. We will now need to adapt the function to be able to place buy and sell orders independent of the start on buy side variable. So let us pass in a parameter and replace every occurrence of start on buy side by the buy side parameter. Now we can use the previously created function in the start function as well as in the onPlaceOrderSuccess function. Here we want to place the order on the opposite side of the order that just got filled. So we use the order and its parameter buy, which tells us whether the order was on the buy side, and then we place the order on the opposite side. Let us next look at the onOrderUpdate function. Here, changes to our placed orders will be notified to the strategy. There are several different scenarios. First, the order could be filled. Then the order could be adapted by the user, cancelled, or adapted and then filled. We also have the case that there has been no change, which we don't need to handle specifically. Then the order could disappear, which would happen before it gets filled, and reappear again if it doesn't get filled, but just disappears from the API of the exchange. The order can also get partially filled, or if there is any other change to the order, it would be notified in the other change case. So first, let us group these. for our strategy, it doesn't make a difference whether the order is filled or adapted and then filled. So we group this into one. Also, it does not really matter for us if whether the order is adapted partially filled or there has been another change. All these cases are the same in that the order remains open, but just some information in the order is changed. Let us ignore the reappeared and disappeared cases for now and move on to the filled state. Here we want to place a new order on the opposite side of the order that just got filled. Also, we should clear the current order variable because the current order is no longer active. Next, the adapted, partially filled, or other change case. Here it is enough to update the current order to the new updated order. Now, the cancelled case. If the user cancels the order, what do we want to happen? Let's do it like the margin ping pong bot does. There we place the order again at the place where it originally was placed by the strategy. This would be done like this. Notice that we don't move it onto the other side here, but keep it at the same side that the current order is at. Okay, but what happens if the order has already been partially filled before? We don't want to place a full order again because that would exceed the amount that was selected by the user. So what we are going to do is pass another parameter to the place order function, which we will add so shortly. And in here, pass current order remaining amount, which is the amount that still needs to be filled on the order. We also should clear the current order variable here. Now let us extend the place order function accordingly. We select the user selected amount as a default value for the variable and replace all occurrences by the function parameter amount. Let's go over the strategy again and ensure that we didn't miss anything, and also clean up variables and functions that we don't use. Let us start here. We never used the strategy state for anything so far, so let us remove it. Okay, we see down here strategy state is used in the save strategy state function, but as we never filled it, it is okay to just return an empty dictionary here for now. Same goes for the restore strategy state function. Here we don't need to do anything right now. We just skipped this get strategy config function. Let us check, did we need any of these data inputs? We didn't use the order book, neither the ticker, nor public trade history, and also not the funds. So we can just remove all of this and replace it by an empty set. Now those functions here won't be called anymore because we just removed them from the required data updates. So we can also remove on new funds as well as the on new public data methods. We might want to add an output in the place order function that the strategy is placing an order. Then we can look at the stop function. We don't need this output anymore. Also, the stop function for us doesn't need to do anything. The same goes for the suspend function and the unsuspend function. Note that even though we don't store any information in the save strategy state function, open orders will already be restored when the strategy is closed and opened again with margin, or when it's suspended and unsuspended by the user. This is done through our margin strategy wrapper that tracks open orders created by the strategy. Thus, if you close margin and reopen it, your strategy will still receive updates for orders that were created before closing margin. Let's keep going down. We don't need the order update status output. Also, we don't need the strategy place order success output. And this output here can definitely go. Also, we don't need to cancel orders in our strategy, so it might be useful to exit the strategy if this ever happens, because would be unexpected behavior. Now it's time to see our newly created bot in action. Let's close the editor window. Now we have to set up the parameters correctly, but before we do so, let us quickly save the strategy and see whether everything is working correctly. Alright, we see that our init function is called, also the get strategy config function will be called, but we don't have any output in there. Also, the whole strategy is parsed and syntax errors would already show up. Now, let us switch to some shorter term window, maybe 10 minutes, and let's set up the parameters as we would like them. maybe a bit below the current market situation and above. So let us choose as a buy price 0.0213 and as a sell price maybe 0.021145. We now switch to the Run Strategy tab. Click on Start and the strategy fails. You can now see the error handling of the strategy editor. First off, down below here, we can see what kind of error we have. It is an assertion error at line 38 in the place order function called by the start function in line 42. You can also see them highlighted in the editor window. The assertion was made that the order is actually valid. But why is it not valid? First of all, we don't have any BTC to place the order. So let us add some funds on BTC side and on the ETH side as well for our bot to be able to trade. Now let's try it again. Click on Run Strategy, then Start. Now we see the limit order appear in the order book. We can also change the position and our strategy should be updated. As we see here, the order was adapted, but it shouldn't change the order that was changed by the user. If we cancel it, however, the strategy should place a new one right away. Okay, what happens if we make the order become filled by dragging it to the opposite side of the order book? There we go. We have a trade and the corresponding limit order on the other side gets placed by the strategy. Here it works the same way. We can just cancel it, then it will be replaced. Or if we drag it over to the bid side, we see a trade and the corresponding order on the other side will get placed. If we just wait long enough, the strategy will do more trades on its own.